Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at is port numbers. Now, what is actually a port? We looked at IP addresses. We saw we have different classes. We have private and public IPs. We saw static IPs. We saw dynamic IPs, right? But how about if I want to make a connection? I mean, think about a port as an entry or an exit. Think about it as you want to go someplace, you have to know the address of that location. So you're leaving your source, which is the source IP address, and now you want to reach the destination IP address. But then when you reach the destination IP address, you have to have an entry to enter that location. For example, watch this. Let me get myself a switch and let me get a few computers, a few client machines. So here's, let's say, a few laptops, one, two, three, four. And let me get myself an actual server and let me hook up the actual cables themselves. So I'm going to go to port one, port two, three, and four, and I'll make the server on port five. Why? Because my server can serve lots of different services. For example, let me give it an IP address. And let's say this one is going to be 192.168 randomly 100.100. Let's say we do have a router. The IP address of the router is 100.254, which is a default gateway, and DNS is using Google's DNS server. I'm going to go to services. I'm going to make this server also as a DHCP server, right? So gateway for my clients is 100.254, and DNS is all eights. Range, let's say we start with 50 for 25 users. And I'm going to save. And let me make sure I'm getting an IP address on each machine. If there's no DHCP, remember we get a BIPA, which is 169.254. Something. That's a private class B address. So I'm just going to go ahead and obtain IP automatically from my DHCP server. And that goes through a DORA, right? Discover, offer, request, and acknowledge. I'm like sending a broadcast to this. It's like, hello, is there a DHCP out there? Right? Then it's going to go ahead and look for one and give me an IP. Maneuver the mouse. I got 100.50/24. It's a Class C private address internally, right? As you see, I do have different numbers here. Now watch this. I'm going to go to the server, go to services. HTTP is actually turned on and HTTPS is turned on. FTP is also turned on. So I want to make some actual connections. Now, when it comes up to port numbers, it falls into different categories. Watch this. So when I go right over here, I have system ports, which is from 0 to 1023. All right. What does that mean? Watch this. So if I go to my server, to the command prompt, right? And I type in, for example, netstat. I mean, it doesn't show any actual connections, right? Oh, watch this. The server's IP address is 100.100. So I'm going to open the browser, right? And I'm going to put 100.100. And I'm connecting to the actual web server, right? This server is hosting a website. Well, if I go to the server and I do netstat, take a look and see what's happening here. It says, first of all, when it comes up to transfer protocols, remember there's two types, TCP and UDP. TCP is a connection-oriented protocol where UDP is connectionless. TCP checks for errors, it's acknowledged, right? It's guarantee on delivery, where UDP is actually faster. It doesn't check for errors. It's not acknowledged. It's most likely UDP is for streaming. Like DHCP is based on UDP. TFTP is based on UDP. Now we have to know port numbers. Look what it says. The foreign, which is my client machine, is 100.50. What port was used on the client machine? 1025. And I connected to my server through HTTP, which is port 80, all right, to my actual server itself. If I go back to the category, it tells me user ports is 1024 up to here. Look how many ports I can have on the system. 65,535. I mean, that's a lot of ports, right? These are actually logical ports, as you see. Based on this connection, I could see what port was used on the source, what port was used actually on the destination. HTTP is port 80. I have to know well known port numbers, right? HTTPS is, for example, port 443. Okay, well, let me go to this machine, and this is 100.52, right? And I'm going to go to the server and connect to it through HTTPS, and that's port 443. So let me open the browser, and I'm going to type HTTPS:// 192.168.100.100. So I did connect with an HTTPS, which is an SSL certificate. Well, let me go back over here and do the netstat. Now it shows me like this machine, it's using this private port number and it's connecting to this server through this public port number, which is 443. Okay, well, let me go ahead and go to this machine, open the command prompt and do FTP to my server. 192.168.100.100. Username Cisco, all right? Password Cisco. Where did I get this from? Right over here. Services, FTP, and I see that information right over here. Well, let me go to the command prompt again, right? And I'm going to see port what? 21. Look what I used on the actual client machine, port 1025, and I connected to my server through a public port, which is what? 21. When I say public ports, these are reserved. Nobody can mess with them. It's for everyone. Linux, Windows, Cisco, name it. Private ports is like nobody cares how you leave your home through a door, through a window, as long as you reach a destination with a proper port number, right? So this actually explains how do I know what is the actual port that is used on the source and destination? And most of them are based on what? TCP. When I look at an IP address and a port number, it's called a socket. Okay. Both together is an actual socket, but my actual IP and then the port number itself. So when I talk about port numbers, take a look at this. There's one thing to keep in mind. System ports are 0 to 1023. For example, FTP is 21. SMTP for sending mail is what? Is 25. POP3 for incoming is 110. IMAP 4 is 143 for incoming mail. Telnet is 23. SSH is 22. DNS is 53. DHCP is 67, 68. HTTP is 80. HTTPS is 443. Remote desktop protocol is private. RDP is like when you make a remote desktop to another server. RDP is only from Microsoft, so it goes under the private range. You see that? Now, when do I use these actual port numbers here? Do you remember when we did NAT? Whenever you do NAT or PAT, it's going to generate like a new port number for you, especially PAT, which is a NAT type. I'm going to get a dynamic port number, which means every time I connect, be using a different actual number. All right. So this explains how TCP or UDP actually works, which is based on source and destination IP address. And especially it's associated with an actual port number. Right. So that's what I wanted to show you in this section. Well, let's take a look and see what we're going to be looking at next. So for now, we'll see you guys in our next section. Bye now.